Okay, this is a video of the notes for Chapter 1, Section 6, Trigonometric Functions. This will be a long one. Okay, we start out with this definition of a sinusoid right here. You could highlight it, that would be great. A sinusoid is a function that can be written in the form of a sine of bx plus c plus d, where a, b, and c and d are constants. Remember that a is called the amplitude. The coefficient of the sine function is called the amplitude. If I factor this b out, this c here is what I will call the phase shift. It is the horizontal shift. D is the vertical shift. I refer to it as the center line because it's the center line of this function. And remember, b, once it's factored out front here, is going to impact what we call the period, the shrinking or stretching horizontally. Okay? The amplitude is the shrinking or stretching vertically. That's a quick review right there. We're going to see several problems where we're finding these, but probably some of the most important part is just knowing what these represent. For me, transformations, the number one spot where you should be talking about transformations is this right here, and graphing using transformations. Okay? A lot of the other functions we can do by just point plotting. This part right here, I cannot stress enough that you highlight this. An inverse sine function is denoted like this. Just like an inverse function is f to the negative 1, the inverse sine is sine to the negative first of x. Or arcsine, they mean the exact same thing. But if you see either of these two notations, you have one answer. One. If you provide any other answer, the problem's incorrect. The key is we're talking about an arc function, so we can only take the inverse sine of the one-to-one portion of sine. It goes back to that one-to-one. So we can only take the inverse sine and a number between negative 1 and 1. Think about it. Opposite over hypotenuse. You can't have a situation where it's 2 or 3 because then the opposite would be larger than the hypotenuse. In the range, this is the key right here. Underline this. This part right here is the most important part. When we do an arc sine, the answer must be between negative pi over 2 and positive pi over 2. It is either a fourth quadrant answer, represented as a negative angle, or a first quadrant answer, such that obviously x equals the sine of y. The inverse cosine, same notation. We can only do the inverse cosine on numbers between negative 1 and 1 for much the same reason here. Same thing, adjacent over hypotenuse. But now our answer is between 0 and pi. Again, one answer anytime we see this notation. So the answer is going to be between 0 and pi over 2 if it's a positive number. It's going to be from pi over 2 to pi if it's a negative number that we're taking the arc cosine of. The inverse tangent, denoted by this, either way, means the same thing, means one answer. We can take the arc tangent on any number, but our answer is from negative pi over 2 to positive pi over 2. Notice it's not included this time because the tangent is undefined at negative pi over 2 and positive pi over 2. There's vertical asymptote there. Okay? We're going to work on this. But essentially, this is something that you had to know from trig last year. You have to know what quadrants you're restricted to whenever it has this arc function or inverse function for these trig functions. Okay? Essentially, it's really the first and the fourth quadrant for arc sine and arc tangent. Just remember the fourth quadrant must be listed as a negative angle. And it's the first or second quadrant for arc cosine. And it's always a positive angle between 0 and pi. Knowing these right here, highlight, 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 huge. Okay? We're going to start out with a little bit different concept. They put some at the front of this. To be honest, it never really pops up in calculus, but these are on SAT. So I'm just going to take a few minutes here to review it because I think it's good material to know, and it is important later on in some math topics. And that is, how do we find the arc length? Use this little formula right here is probably the easiest way. The arc length is always the radius times the central angle. So S stands for the arc length. I wrote it right here for you. R equals the radius. And theta is the central angle, but it must be in radians. So they're always going to give you two of the three. In this first example here, they give you the angle in radians and they give you the radius. If I want to find the arc length, I take the radius times the angle. I can reduce and get 5 pi over 4. That is the answer, the exact answer, but if we want a decimal representation, what is that number? We type it into our calculator and it is 3.927. If the radius is in inches, then this arc length is in inches. So look at this one. They give us the angle in radians. Remember, sometimes it'll be in degrees and you'll have to convert it to radians. The radius is what we're looking for this time, and they tell us the arc length. We plug in 3 pi. Here is the radius. Here's pi over 6. Multiply by the reciprocal. Multiply both sides by 6 over pi. The pi's cancel. We get a radius. Again, if the arc length was in feet, this would be in feet. Okay? Okay, moving on. Here are some of these arc problems. One of the first things that you do need to know, I expect that everybody has the 30, 60, 90 right triangle memorized. Across from the 30-degree angle is 1, across from the 60-degree angle is the square root of 3, and across from the hypotenuse is 2. So when I am doing the arc sine of a positive number, if you can just remember that the arc function of a positive number is always a first quadrant answer. In calculus, we will always be in radians. This is the only time that they ever ask for an answer in degrees in this class, is in this section, Chapter 1, Section 1. Everything we do in calculus is in radians. You want to make sure you set your calculator in radian mode in this class. For those that have physics, you have to switch it back and forth because you use degrees more in physics. In calculus, always radians. So here's what I'm doing. I wrote this as a fraction, and if I'm taking the arc sine of a positive, I know it's a first quadrant only. Even though the sign is positive over here, I don't want. It doesn't say from 0 to 2 pi. I want one answer when it uses this notation. So I write opposite over hypotenuse. You can do the Pythagorean theorem, or hopefully you can recognize, oh, if that's 1, that's 2, this is the square root of 3. It's the 30, 60, 90 right triangle. Therefore, across from 1 has to be a 30-degree angle. 30 degrees is the same as pi over 6. I would expect that you have these memorized as well. That pi radians equals 180 degrees. Okay? Pi doesn't equal 180. They're two different units. It's like feet and inches. You can't say 12 equals 1. 12 inches equals 1 foot. Pi radians equals 180 degrees. Pi divided by 2 radians, pi over 2 radians, therefore is 90 degrees. Pi over 3 radians is 60 degrees. We should know it like that. Pi over 4 radians is 45 degrees, and pi over 6 radians is 30 degrees. We need to know those 5 immediately, because then we can rotate any angle if we know those 5. So some of these I would expect that you can do without using your calculator like this, and it's more likely that you will see this in an AP application. But here's an example of the inverse tangent of a negative number. We have to know which quadrant. Only one answer. That's why I like you to draw the triangle, so you are indicating what quadrant your answer must be in. I could write this as negative 5 over 1, so I could go opposite over adjacent. Remember, all students take calculus. That means all of the trig functions are positive here. Only the sine and the reciprocal, the cosecant, are positive here. Only the tangent and the reciprocal, the cotangent, are positive in the third quadrant. And only the cosine and the reciprocal secant are positive in the fourth quadrant. Okay, so all students take calculus. So if the tangent is negative, all students take calculus. It's positive in the first and the third. It's negative in the second and the fourth. Why do we pick the fourth quadrant? Because of that range we just talked about. that the answer must be from negative pi over 2 to positive pi over 2 only, every time that we have this notation. So I draw this picture in the fourth quadrant. It's opposite over adjacent. Well, that's 25 when I square it. That's 1 squared. I can add them together, take the square root. I can write the hypotenuse, but I'm not going to recognize this. This is not a special right triangle. If it's not one of those two special right triangles, then we need to use our calculator. If we're in degree mode in our calculator and we type this into our calculator, we get out negative 78.690 degrees. That should have a degree symbol on it right here. Okay? If it's in radian mode, and all you have to do is convert it to radians to get this answer. So let me show you quickly on the calculator so you know where the buttons are. Okay? Clear this out. I'm going to be in degree mode first, just so the answer makes a little bit more sense. Okay? So that's how I convert it. I'm going to go second quit. I'm going to go second inverse tangent of negative 5. The good part about the one answer that we're searching for, it's the one that the calculator is going to tell you every time. If it's a calculator problem, just plug it into the calculator if you have the calculator on the AP test. Okay? To convert this, I don't have to retype it in. I just have to go second mode. I have to go mode. Go back to radian mode. Hit enter. Second quit. And when I'm back to the home screen, just hit enter again. It will take the last thing that you plugged in. There it is in radian mode. You don't have to retype it in. Just hit enter. Okay? There are the two answers. Believe it or not, these problems are some of the most problematic out of this section because students are still unsure which one answer they should provide. Use your calculator to check. Okay? But know your ranges. Know which quadrant you must draw. It's pretty easy. If you do the arc trig function of a positive number, it's always the first quadrant. So let's just, there it is. It's one answer in the first quadrant. If you do the arc trig function of a negative number, that's where it gets tricky. If it's an arc sine or an arc tangent of a negative number, it's a fourth quadrant angle listed as a negative angle every time. The tricky one is the arc cosine of a negative number. The cosine is negative in the second and the third quadrant only. So we pick the second quadrant and our answer is listed as a positive angle between pi over 2 and pi. Okay? But we have to know how that works. Okay, so you're going to get some practice on that. And then the other part that you have to be able to do is you have to be able to graph some of these trig functions. So we're going to draw, this says y equals sine of x and y equals cosecant of x. From negative pi to pi, I actually drew it further than this just so that you get used to it. What I think is more important is that you can identify these, that you know what the amplitude is and how it's impacted. You know what the center line is. You know what the phase shift, and that's the horizontal shift left and right. You know how to deal with the period. The standard period of sine and cosine is 2 pi. And this increment here I will explain as we go. Okay? Let's just say that I forgot to what the sine of x looks like. Okay? So I'm going to graph some points and see if I can't put this together. It also gives me a chance to review this concept right here, the concept of quadrantal angles. When you are evaluating the sine of a quadrantal angle is an angle that lands on an axis, 0, 90 degrees or pi over 2, 180 degrees or pi, 270 degrees or 3 pi over 2, okay, 2 pi or 360 degrees. Any rotation of that. Any angle that lies on an axis. When we are taking the sine of a quadrantal angle, we draw the unit circle instead of a triangle because we know that the sine of a quadrantal angle always equals the y coordinate. The cosine of a quadrantal angle always equals the x-coordinate. The tangent of a quadrantal angle is sine over cosine. That's why y over x. We have to know this. If you think about it, essentially what we're saying here, it's still opposite over hypotenuse, right? If you draw yourself a triangle, okay, it's just that the opposite and the hypotenuse are the same. Think of it that way. That's why it's the y-coordinate. Okay, so let's go. Let's just plot some points here as I'm plotting this. So I'm going to start at 0, pi over 2, pi, 3 pi over 2, 2 pi. Using this right here, I'm graphing the sine first. So to graph the sine of 0 is the y-coordinate at 0 is 0. I plot that point right there. The sine at pi over 2 is the y-coordinate. It's 1. The sine at pi is the y-coordinate at pi is back to 0. The sine at 3 pi over 2 is the y-coordinate at 3 pi over 2. It's negative 1. The sine at 2 pi is back to here's the y-coordinate at 2 pi, 0. I could do the same thing working backwards. At negative pi over 2 is here, at negative pi there, and here it is. So it's negative, 0, positive, okay? And we sketch that in. There it is. There's the sine function, okay? Here's what we need to know about the sine function. At our phase shift, the sine function starts on the center line. If it has a positive amplitude coefficient, it goes up first. If it has a negative amplitude coefficient, it goes down first. That's what we have to know about how to start sine. Okay? Just to review this, make sure our amplitude here is 1. There's no coefficient in front of the sine, so it's assumed to be 1. The center line is y equals 0, or the x-axis, because there isn't a constant being added or subtracted to the sine function. The phase shift is 0. We're starting at 0 because there isn't a value added or subtracted to the argument of x. And the standard period for sine is 2 pi. It's 1 revolution. This increment here is always found by taking the period divided by 4. Mr. Simpson calls it the quarter period. It's much better description than what I use. I've just always called it the increment, and I haven't changed my documents. But if you want to call it the quarter period, that's what it is for sine and cosine curves. It is the quarter period. Take the period divided by 4 to get this increment every time. And I show the work here. What is the increment? I'm starting at 0. I'm adding pi over 2. I'm adding pi. I'm adding pi over 2. I'm adding pi over 2. So I'm adding pi over 2 each time. Okay? Or subtracting pi over 2 each time. That's the increment between each critical point. What about the cosecant? Notice that I boxed this in red. Whenever we're graphing a cosecant or secant function, we're going to graph the sine or cosine function first. Everywhere that the sine or cosine function crosses the center line, we're going to dot in a vertical asymptote like I've done here. Because the reciprocal of 0 is undefined. That's why they become asymptotes. Not only that, but the reciprocal of a really small number, a number that's really close to 0, is a really big number. So what happens is we start at these maximum points and they go up, and we start at the minimum points and they go down, because the reciprocal of a really small number is a really big number. The reciprocal of a really small negative number is a really large number in the negative direction, right? So the reciprocal of this becomes a large negative. Reciprocal of this becomes a large negative. So just remember, high points go up, low points go down. You would dot in the sine curve as your guidance, and then just put the solid curve in going up or down is how we graph arc secant and arc cosecant. Should have done it pretty extensively last year in your trig class, but we'll practice it a little bit. And to be honest, it's not like you're going to have to graph this on the AP test, but you're going to have to recognize graphs, recognize phase shifts and how they work, period coefficients and how that impacts solutions, okay? It's more the recognition of all of this, and having a graphical representation sometimes can help. Let's take a look at a more complicated one, but not all of the 4 shifts, just 2. and it gives us an opportunity to look at the cosine. Okay? Remember the cosine curve. If I did this same situation here, okay, if just looking at this to sketch cosine, and I'll do it with this circle here, the cosine of x would be the x coordinate. So at 0, the cosine would start at 1. Cosine refers to the x coordinate of the unit circle. So at pi over 2, the x coordinate is 0. At pi, the x coordinate is negative 1. At 3 pi over 2, the x coordinate is 0. At 2 pi. So here is the cosine curve right here. Okay? So what I need to recognize is this. The sine curve starts on the center line at this phase shift. It goes up first if the amplitude coefficient is positive. It goes down first if the amplitude coefficient is negative. Cosine curve starts either above or below the center line at the phase shift. If we have a positive amplitude coefficient, the cosine starts above. We just did one. If I wanted to graph y equals negative cosine of x, it would just be reflected in the x-axis. We'd start down at negative 1 and go this way. It's all about knowing how to start the curve. Cosine starts off the center line. Sine starts on the center line. Cosine starts above if we have a positive amplitude coefficient, starts below if we have a negative amplitude coefficient. Sine starts upward if we have a positive amplitude coefficient, downward if we have a negative amplitude coefficient. Okay? Keeping that in mind, let's take a look at the cosine. So here's how we're going to do it. First of all, the coefficient here is 1/3. It is not 3. I'm not multiplying x by 3. I'm multiplying x by 1/3. The amplitude coefficient is 2. Real quickly, the amplitude is always presented as a positive number. If it is a negative coefficient, that will impact how we start the curve, but we always define the amplitude as a positive value because it's defined to be the distance away from the center line, up or down from the center line. Okay? The center line here is y equals 0. If this said minus 5 as a term added to this, then y equals negative 5 would be my center line. But I do not have a center line in this problem. The phase shift is 0 because I'm not adding or subtracting anything to the argument of x. So it's the standard phase shift. My period here, this just has a period change. The period is always going to be 2 pi over this coefficient of x. Sometimes students will divide this by 3, thinking the coefficient is 3 instead of 1/3. 2 pi divided by 1/3, when you multiply by the reciprocal, is 6 pi. My increment, therefore, is 1/4 of the period. It's the quarter period. So take the period, divide it by 4, 6 pi over 4, always reduce your increment. So what's happening here on this curve? First of all, draw in your center line, but do not draw in the y-axis. That goes in last. Start at your phase shift. In this case, it is 0. And add your increment. You have to be able to add fractions. 0 plus 3 pi over 2 is 3 pi over 2. 3 pi over 2 plus 3 pi over 2 is 6 pi over 2. That reduces to be 3 pi. 6 pi over 2 plus 3 pi over 2 is 9 pi over 2. 9 pi over 2 plus 3 pi over 2 is 12 pi over 2, or 6 pi. And you got to be able to add fractions that quickly. Subtract 3 pi over 2. Subtract 3 pi over 2. Subtract 3 pi over 2. I can work in this direction as well. But here is the key. The cosine starts off the center line. So at the phase shift, we are not going to start at 0, 0. We start up here, like the normal cosine curve would. Real quickly, if this was a negative 2, everything would be the same except we'd start right here. we would start down below the center line. That's the only thing that amplitude does. It reflects the graph in the x-axis. But if I have a high point, I have to hit 0 before I go to a low point. I have to hit 0 before I go to a high point. I have a high point, I have to hit 0 before I go to low. I have to hit 0 before I go to a high. And then I sketch it in. The very last thing that you're going to want to do is draw in the y-axis, because sometimes we're not going to go through 0. In this case, we do. So we can draw it right in here. Then label y equals 0 is the center line, but my amplitude is 2. So I've got it labeled. This is 2. My high point is 2. My low point is negative 2. Okay, I'll give you a chance. Give everybody a chance to get that written down, or you can pause it. And now we're going to do one that's going to be a lot of stuff going on. This one will take some time to get through. Okay, so let's do this more complicated problem. I made it a reciprocal function. I have all 4 of the shifts going on. Are you going to see something like this? Not likely. But if you can handle all of these, number one, you should know how all of your transformations work. And you should be able to handle anything that they might throw at you. So let's just start. If this coefficient is inside the parentheses, the first thing you want to do is factor it out front. You're just dividing both terms by 3 when we pull it out. So if I distribute, I would get back to this. I'd get 3x, the 3's would cancel, I'd get back to this. But we always want that coefficient out front. Otherwise, we forget to divide by that coefficient when we're finding our phase shift. This. First of all, it's important to know that cosecant and secant do not have an amplitude. In this box, I write none, but I put 3 and I circle it because it certainly is going to stretch this graph. It's going to have an impact on this graph. Okay? However, it is not the amplitude, because amplitude is defined to be the distance away from the center line. Okay? And this goes up forever, goes down forever, secant and cosecant functions. So we'll just put none here. There is no amplitude, but we're going to put a 3 and circle it so we don't forget the impact that this is going to have on our graph. The center line is y equals negative 2. Center line means it cuts the top from the bottom. Phase shift is always the opposite of whatever you're doing to x. So negative pi over 3 is the phase shift. And again, we have to have this 3 factored out front before we can determine our phase shift. That's why we write it this way. The period right here for sine and cosine is always 2 pi over this coefficient, the coefficient of this x. Whether it's out in front of the parentheses or whether it's in here, it's this coefficient. Now it is 2 pi divided by 3. And then I have to take 1/4 of that to figure out my increment, or my quarter of a period. When I multiply this by 1/4, I didn't have to do it this way. When I multiply by 1/4, I'm going to get 2 pi over 12 when I multiply by the reciprocal and reduce. So I'm adding pi over 6 each time. A lot of students think the period is where we have to end up. That's not true. If I start at 0, this will be the angle that my graph ends. But if I have a different phase shift, the period is the distance from start to end of one period, or one cycle. So on this problem, we are starting at negative pi over 3. I'm starting here. The reciprocal of, this is the reciprocal of the sine function. Okay? Now there is one little change that I made on this, and I didn't indicate it here, but when I did it for students in class and on my sheet, I'm going to show you here. So I'm going to go to this real quickly. Okay? Is that I want this to be a negative 3, so that you can see the implication of it being a negative amplitude. So really, the amplitude coefficient is negative 3, although there is no technical amplitude on this problem. You're going to see right here how that plays out. But again, the very first thing we want to do is draw in the x-axis. Don't draw in the y-axis. We may or may not land on 0. But my phase shift is where I'm going to start, right here. That's where I start. And then I'm going to add pi over 6 each time. I'm just going to add my increment. Increment means add. Add, 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 add. Now I need to be able to add fractions. So I'm going to go back to the other screen so you can see it a little bit better. Okay? I'm adding pi over 6. So negative 2 pi over 6 plus pi over 6 is negative pi over 6. Negative pi over 6 plus pi over 6 is 0. 0 plus pi over 6 is pi over 6. Pi over 6 plus pi over 6 is 2 pi over 6, which reduces to be pi over 3. You must reduce. Watch this one. 2 pi over 6 plus pi over 6 is 3 pi over 6, or pi over 2. 3 pi over 6 plus pi over 6 is 4 pi over 6, which reduces to be 2 pi over 3. With the sign, remember the cosecant is the reciprocal of the sine function. And again, we have a negative sign. Remember, there's a negative right here. There's a negative there. Okay? Because that negative sign will tell me this sine function is not going to go up first. It's going to start at the center line, and then it's going to go down first because of that negative that I put in there. Okay? So it's going to go down, then cross, up, then cross, then down, then cross. Going back this way, it goes up first. We dot in that sine function. Notice it's dotted, not solid. And everywhere where the sine function has a 0, we dot in a vertical asymptote because the reciprocal of 0 is undefined. So everywhere where it crosses this center line, we dot in a vertical asymptote. Then high points go up, low points go down. High points go up, low points go down. It is actually graphed in blue. Remembering though, there's a negative sign there, a negative sign there, a negative sign there. Okay? I meant to change that, and I didn't get it typed in. Okay? But I want you to see how the negative changes the sine curve. Okay? Questions on that one? Obviously, you can't ask a question, but I'm going to leave it here for a minute so you can get it down. This is a tough one. We'll look at some. I'm not going to put anything this tough on a test or quiz. Okay? Okay. These, however, I will for sure. Many students will get these problems confused with the arc sine and arc cosine. Arc sine, arc cosine, arc tangent. One answer. Here, we're going to have more than one answer because of this domain that they give us right here. This says we want to know the tangent of what angle equals the square root of 3, and we want to find any angle between 0 and 2 pi in one complete revolution, where there are 2 times where the tangent equals a positive square root of 3. All students take calculus. The tangent is positive in the first quadrant because all of them are positive in the first quadrant. And the third quadrant. Take stands for tangent. Draw yourself the triangle. This is square root of 3 over 1. Tangent is opposite over adjacent. Square root of 3 over 1 means the hypotenuse has to be 2. We have to recognize this is a 30, 60, 90. Opposite is negative square root of 3 over adjacent is negative 1 because that still gives us positive square root of 3. Hypotenuse is 2. Across from the square root of 3 is a 60-degree angle. So this is 60 degrees. The third quadrant is going to be 180 plus 60 is 240 degrees. But we need our answer in terms of radians. We need to be able to convert these quickly without showing any work. We need to know that 60 degrees is pi over 3. We're going to see it enough. We've got to recognize it's pi over 3. And 240 is just 4 times 60. It's 4 60-degree angles. It's 4 pi over 3s. Done. That's how quickly we're going to convert them. Let's do another one. Anytime I'm dealing with the reciprocal identity, cosecant, secant, cotangent, I want to rewrite it using sine, cosine, or tangent and just take the reciprocal of this number. We always start by seeing if we can draw triangles in the correct quadrant. All students take calculus. The sign is positive in the first quadrant because all trig functions are positive in the first quadrant. And it's also positive in the second quadrant. Students stands for sine. All students. Sine is positive here. Why is it positive? Because the opposite over the hypotenuse. This is a positive distance. The hypotenuse is always positive. It's positive here. Opposite over hypotenuse. That's upward is a positive distance. Yes, this is negative, but that's not going to impact the sine. It impacts the cosine. So I complete my triangle by writing the square root of 3, knowing that this is a 60-degree angle, but the angle I'm looking for is across from 1, so it's a 30-degree angle is the answer. I have 30 degrees. Remember, if I come over to here, it's 180 minus 30 is 150 degrees. Again, on the conversions, we have to recognize that 30 degrees is pi over 6. We have to know it like that. Okay? 180 divided by 6 gives me 30 degrees. Pi over 6 is 30 degrees. 150 is just 5 times 30. So it's 5 30-degree angles. It's 5 pi over 6's. Done. We're going to do it that quickly. These are critical that we can solve these fairly simple trig equations because we're going to get some that are a lot more complex, especially when we look at the Chapter 0 workbook. Let's do this one. Notice this time it says from negative infinity to positive infinity. Let's talk about how that gets impacted. First of all students take calculus. The sign is positive in the first and the second. Therefore, the sign is negative in the third and the fourth. And you can just think about it, right? The opposite will be negative now because it's a downward direction. Opposite over hypotenuse is going to create negative sign values in the third and the fourth quadrant. We have square root of 3 over 2. Opposite square root of 3, hypotenuse is 2. And we need to recognize this is a 30, 60, 90 right triangle. Or you can do the Pythagorean theorem to figure out that that's 1. That's negative 1 because it's going backwards. There are 2 angles in one revolution. So let's find those 2 angles. 180 plus 60 degrees, because across from square root of 3 is 60 degrees, would be 240 degrees. 360 degrees minus 60 degrees will be 300 degrees. But they have to be in radians. This is 4 60-degree angles. 4 pi over 3. Pi over 3 is 60 degrees. This is 5 60-degree angles. 5 pi over 3. That quick to convert. Then, since it goes from negative infinity to positive infinity, I have to add 2 pi n to each one of these. What does that mean? It's understood that n, and you don't have to write, n is any integer value. So essentially it's saying, yeah, this angle works, but any revolution of this angle works in the forward or negative direction, as long as it has the same coterminal side. This will say any angle that has the coterminal side by adding 2 pi n. This is saying we can add any revolution. Same here. This angle you could add or subtract. So really you just have to remember to add 2 pi n anytime it says from negative infinity to positive infinity when we're doing these problems. Okay? Last one is a calculator problem. And it's tricky because it wants an answer from 2 pi to 4 pi. It's a little bit tricky. I still start by drawing the triangle so I know where my answer should be. The tangent is positive. All students take calculus in the first and third quadrant. This is opposite over adjacent. I do the Pythagorean theorem, 25 plus 4, take the square root just to get this. But this is not going to be a special right triangle that I'm going to recognize. So I have to use my calculator. If I do an inverse tan of 5 halves in my calculator in radian mode, and I tell you right here, you only get out 1.190. Uh-oh, that's kind of a problem. I need this one as well. Well, it's the same reference angle, so I have pi plus that reference angle. What is pi? 3.14 plus this. I do that in my calculator. I get 4.332. These two values of x will be the first rotational values. But I want the second rotation. I want from 2 pi to 4 pi. So I got to add another 2 pi to each one of these. When I add 2 pi, I get 7.473. When I add 2 pi to this one, I get 10.615. Let's think about it. Let's see if these two values make sense. Remember, pi is 3.14 times 2. 3.14 times 2 is 6.28. Yeah. This is larger than 6.28. This is larger than 6.28. But if I take 4 times 3.14, right, you're going to get over 12, right? A little bit more than 12. So these two values are in between 2 pi and 4 pi. They make sense. These two values are not. These two values are not between 6.28 and 12.56. They're not. Okay? So you have to know how the rotation works on those as well. Okay, this has been a long video, and we still have a bit more to go because we have to deal with these rotational situations as well. In other words, if I have a coefficient in front of my x, my argument, it could be theta, could be x. Let's take a look at this. The tangent of 3x equals 1 over the square root of 3. Here's what I do to try to simplify the process. Remember we used that u substitution before? I'm going to do it again. I'm going to say u equals 3x and rewrite this as the tangent of u equals 1 over the square root of 3. I can draw this picture. The tangent, all students take calculus. Tangent is positive in the first and the third quadrant. Tangent's opposite over adjacent, 1 over the square root of 3. That's the square root of 3. This is negative 1 over negative square root of 3. In both cases, the hypotenuse is 2, and the reference angle is a 30-degree reference angle. 30 degrees is the same as pi over 6. If I have pi plus pi over 6 is 7 pi over 6. Or you can think 210 degrees is 7 30-degree angles. Okay, so these are my two answers for u, but here's the problem. This 3 essentially tells me I'm going to have 3 cycles, 3 periods, where I normally had 1 period. So I have to look at 2 more revolutions. How do I take the revolution of the same terminal angle? I add 2 pi. 2 pi is the same in this case as 12 pi over 6. Pi over 6 plus 12 pi over 6 is 13 pi over 6. Add another 2 pi. Add another 12 pi over 6 is 25 pi over 6. Same with this one. Add 12 pi over 6, add 12 pi over 6. But here's the problem. This number now is not in here, right? Well, that's because these are the values for u. I need to solve for x. If I want to get back to x, I have to multiply each u by 1/3, don't I? The opposite of multiplying x by 3 is to multiply both sides by 1/3. So if I'm going to solve, if I have this value for u popped in here and I want to solve for x, I have to multiply both sides by 1/3. So every one of these values has to be multiplied by 1/3. It's just going to change the denominator to 18. Now, are all of these values between 0 and 2 pi? Yes. 2 pi is the same as 36 pi over 18. So all of these values are between 0 and 36 pi over 18. Look at the numerators. They're all in this interval for our answers. So essentially you need to know this coefficient is going to tell us how many rotations we need to look at. And then once we solve for u, it tells us what we have to divide each one of these answers by. Or just multiply by 1/3, the reciprocal of this. Multiply u by the reciprocal of whatever's being done to x. Let's take a look at another one. Again, this is a cosecant, so I'm going to change it to sine, and I'm going to reciprocate the right side. I always want to rewrite in terms of sine, cosine, and tangent. I'm going to say u equals 3x. It may help some of you to write down 1/3 u equals x. Same thing, right? When we go backwards, we're going to multiply each u by 1/3. So the sine of u equals 1/2. I don't know why that was cut off there, but 1/2. Sine, students, take calculus, is positive in the first and the second quadrant. Opposite over hypotenuse makes that the square root of 3. Opposite over hypotenuse makes that negative square root of 3 because it's going backwards. Always use the correct sign as you're labeling these sides of the triangle. That way you won't make a mistake. Across from 1 is a 30-degree angle. So this is 30 degrees or pi over 6. Okay? Or this is 150 degrees or 5 pi over 6. Now, you don't have to write down all the values of u if you can realize I've got to multiply by 1/3. So pi over 6 multiplied by 1/3 is pi over 18. 5 pi over 6 multiplied by 1/3 is 5 pi over 18. The denominator is just changed into 18. Okay? And then what you can do instead is instead you can take the period, which was 2 pi, instead of adding 2 pi, I got to divide that by 3. So I'm going to add 2 pi over 3 each time. So pi over 18 plus 2 pi over 3 is 12 pi over 18. So I'm adding 12 pi over 18 each time to get from here to here, from here to here. You decide. I gave you 2 different setups in which I found all the values of u first, and then I multiplied each u by 1/3. Or where I find the first revolution, divide those values by this coefficient right away, and then instead of adding 2 pi each time, add 2 pi divided by that coefficient, so that I don't have to write down this second set of numbers each time. I can get to the answer right away. Some of you are going to prefer this, because I just add 2 pi, and then multiply by 3, do it as 2 steps. But you have to decide. Last one. Sometimes we get things like this. This is probably more likely on an AP test. We run into this. And this is why I like this u substitution. U equals pi over 3x. Therefore, the sine of u equals negative 1/2. All students take calculus. I draw my triangles in the third and the fourth quadrant because that's where the sine is negative. Sine is opposite over hypotenuse. Opposite over hypotenuse makes that the square root of 3 and the negative square root of 3. But I need to know across from 1 is a 30-degree angle. So this is 210 degrees or 7 pi over 6. This is 360 degrees minus 30 degrees, 330 degrees, or 19 pi over 6. Okay? Okay, let me say that again. So I have 7 pi over 6, but this angle here is 330 degrees, which is the same as 11 30-degree angles, or 11 pi over 6. This 19 pi over 6 comes from the next revolution. If I take this angle and go around again, I have to add 2 pi. 2 pi is the same as 12 pi over 6. If I take the next revolution here, if I add 2 pi, get a common denominator, add 12 pi over 6 is 23 pi over 6. I could keep looking at revolutions, but I want my answers to be between 0 and 10. Remember, each value of u is going to be multiplied by 3 over pi to solve for x. If u equals pi over 3 times x, then x equals 3 over pi times u. So each u is being multiplied by 3 over pi. Cancel the pi's. 3 and 6 cancel to give 7/2. Let's do this one next because that's the next smallest. Multiply by 3 over pi. Pi cancels. 6 divided by 3 is 11/2. It's right here. Maybe I can fit another one in. Let's see. Multiply by 3 over pi. Divide the pi's, reduce 19 over 2. 19 over 2. That's 9.5. That works. But this one here, if I multiply by 3 over pi, the pi's cancel, reduces to be 23 over 2. 23 over 2 is not in that interval. Therefore, we stop, and these are the 3 solutions. Just over 50 minutes. In class, I'm going to actually do these problems as we go, and it's going to take a couple days. So if necessary, go and look at that video. But this video right here you can reference as well in case you just want to pick up something little that I might have said. Okay?